All right, ladies and gentlemen, welcome to this continuation of the student presentations in the course on technology and the future of medicine. Now we have Ian Stefanuk talking about morality and machines. Should we expect Skynet or Wall-E? Take it away, Ian.
My name's Ian. Today I'm going to be talking about morality and machines as we approach the singularity. As this title says, should we expect Skynet or Wall-E as we move forward? So the relationship between morality and machines I'm quite interested in. I wanted to know what a computational morality might look like in AI and how it might develop. So that's why I chose this for my project. Some researchers at the University of Washington have been doing some pretty interesting research. They've been looking at how humans respond to a robot. In this video I'm going to show you here, this robot is controlled by researchers in another room, similar to like in The Wizard of Oz. They're controlling this robot to make it appear sentient to this research participant. And this robot is basically telling this participant that they have lost at this research game and they don't win the prize. So I'll just go ahead and show you that video. Okay, so the interesting thing about that video and why it's very relevant to what we're talking about today, basically these participants are accusing this robot of rigging the research game, of lying to them, both of which we would consider to be moral transgressions and something that you would need a morality to talk about. So it seems that we're already at a point where humans are intrinsically thinking that it's plausible that this robot in front of them is sentient and has a moral code. So today I'm going to be talking first on some concepts that I'll be introducing or using in this presentation, going over some of the negative and positive possibilities of a computational morality. I'm going to talk about how we can create a morality in an artificial intelligence, and then lastly what we can do to limit some of the negative possibilities that I'll go over. So you guys are probably familiar with these concepts, but just for clarity's sake, I'll go over them. I'm using Kurzweil's definition of the singularity being the point where a superintelligence is created. I'm using Bostrom's definition of artificial intelligence, or AI, to be a mechanical agent that outperforms humans in virtually all fields. The focus of this presentation is on AI sentience. So we talked in Thursday's class on sentience in animals and the potential that some animals are sentient, but this will be a focus on artificial intelligence sentience. So if we look at this graph, this isn't for artificial intelligence specifically, but it shows the relationship between complexity and mentality. So if we look at these top levels here, this might be what we consider sentience. So it's having a moral code, being able to self-reflect, thinking about our own consciousness. So this graph is showing in biological systems how the level of complexity increases and the sentient aspects of consciousness are therefore reached. And now Chalmers and other AI researchers think that a similar progression will be seen in artificial intelligence and computer systems. So with a certain level of complexity, once that threshold has been reached, then they believe that AI will gain sentience in a similar fashion to these biological systems here. So why do we need to plan ahead? As referenced in the title, we want to know whether, as we approach a singularity, and AI sentience, should we expect AI that's closer to Wall-E, who is wanting to help humanity and working together to save the world, or should we anticipate something like Skynet from the Terminator, who is kind of bent on human destruction? So it's easy to see that once the threshold of sentience is reached, that Chalmers and other researchers believe will happen, the AI will have its own consciousness, and this will be a very big thing for us. So we're going to look now at some of the negative and positive possibilities that could result from having a moral code in a computer system. But I will say now, whether they're good or bad depends on what you think of the machine-human relationship and what you want for our future. So I'm saying things in a negative sense would be something that would challenge our human-machine relationship as it currently stands, but someone who is a singularist or a transhumanist might not see that alteration to our relationship as a bad thing. So you can take from this what you will, if it's positive or negative. We're starting off with the negative possibilities, so we can end on a positive note. But with the negative possibilities, we're going to look at AI that's more moral than humans and AI that is less moral than humans. So again, I have to say, humans don't, it's hard to say what's more or less moral, because it depends on your religion, your society, your upbringing. So for the purpose of this presentation, AI that is more moral than humans means that they have a more restrictive moral code. So they have more laws governing what they can and cannot do. Therefore, less moral AI would have less restrictive moral code, and they would have less laws telling them what they can and cannot do. So again, we don't know what's moral. In terms of more moral AI and some of the negative possibilities that can come from that, if this were to be the case, and they were more moral, then AI may take a governing role in the human-AI relationship. So a sentient AI may see humans as immoral, which we often are, and attempt to restrict our activities so we can, the harm that we can cause ourselves and this Earth will be limited. So an example of that would be Vicky in the movie I, Robot. If you are familiar with the movie, this artificial intelligence gains sentience and realizes humans are actually the worst, and this artificial intelligence then attempts to regulate humankind by restricting the harm that they can cause to the Earth and other humans. So that's some of the negative possibilities from an AI that's more moral or has a more restrictive moral code. It might be a bit easier to see from the less moral standpoint, however. When we have AI that does not have the same value for human life or has a moral code that doesn't place the same value on things that humans value, if we have goals that conflict, then they won't stray from harming humans. This would be an example of a war machine gone rogue, or something that when the goals conflict with humans, they won't value human life, so they would likely try and remove humans in some way. It's important to note that this would be the default scenario if we do not properly plan for the approaching singularity and when sentience is reached by AI. So if we don't program this computational morality, or at least plan for it, then this will be the default scenario, which is not super awesome. Some of the positive possibilities that can come from a computational morality, again, whether these are positive depends on the person. First off, if we are able to model human morality with a computer program, it might give us more insight into human moral decision making. So if we can have a computer system that we can study thoroughly, we can maybe look at underlying universal moral ethics or things that are applicable to human moral decision making, and that will help us understand ourselves better. Secondly, if we can model our human reward system on a computer, this might help us to give us more insight into human disorders that are that reward system gone awry. So we might be able to look at addictions or eating disorders where our reward system is being impacted in a way we don't understand at this moment. So if we can understand it using a computer model, it might help us with treatments for those disorders. Thirdly, and this is where it gets a little bit challenging, so a computer system that has a programmed morality in it may be able to be used as a sort of judge in a morally ambiguous or complex situation. So if you think of a courtroom, it could analyze a lot of information, a lot of input, and this computer system wouldn't be necessarily swayed by the same things that a human judge might be swayed by, things like emotion or other very human factors. It could be argued that a computer system that has a modeled morality could be a good judge in a scenario like this. And lastly, which is even more, a little bit stickier, a moral tutoring system. This is proposed by some researchers as it's kind of the idea of making a computer system that would teach a moral code, the moral code of a society to an individual. So it could be used sort of in a step-by-step way to teach children the proper morals of their society, or as part of a rehabilitation program for a criminal or someone who has shown that They don't necessarily have the right morals of the society. So this is one idea. It's easy to see how this would be quite a bad thing if in the wrong hands or used in the wrong manner. So this would be a particular instance where we would need to carefully consider what we're doing with that. Okay, so how do we create this computational morality? For anyone who has taken developmental psychology classes or anything to that extent, you might recognize these stages of moral development. Kohlberg is the psychologist here, and he basically is saying that as humans mature, our moral code is based on different things. So in the first level, in the beginning stages, what we do is based on external motivations. So things that are external to ourselves, like rewards and punishments in our environment. As we move to the second and third level of this moral development, then we choose our actions more on intrinsic motivations, so things that are coming from within ourselves. This will be abstract concepts like what is just, what is morally right, what is morally wrong. So that's the sort of progression. We can use Kohlberg stages to explain in context where we currently stand with computational morality. So the earlier stages, as I mentioned, are based on external rewards and punishments only. And this is where computational morality is currently at. So we're limited to these earlier stages because we can't model in a computer system what right is and what wrong is or what universal justice is. We just don't have any way to represent that at this moment. So we're restricted at this moment in the earlier stages of Kohlberg's moral development, at least. So this gives us an unfortunate catch-22 with AI morality. So basically, AI researchers cannot program for a moral code that's at Kohlberg's higher levels, so the ones that are looking at social justice and universal right and wrong, because we don't have a way to code for that. So we can't code for that prior to sentience being reached in these robots. However, if AI sentience is reached without us having that moral code in place, then there wouldn't be anything governing these newly sentient robots and telling them what they can and cannot do. So it would be likely that some of the negative possibilities that I've spoken about could result from this if we haven't prepared. So we can't prepare, but if we haven't, then things will go maybe not so well. So it's unfortunate. But with AI and with robots, we do have a little bit, we have some unique aspects to the reward systems that we can use. So we are restricted to external rewards and punishments, but it's a bit unique in how we use them. So with robots, even a certain light wavelength or other seemingly trivial stimulus can be made rewarding or punishing, depending on if the programmer decides to make it so. Basically, as humans, we're restricted by our evolved reward system that's in our brain using dopamine and neurotransmitters. But with the robot and with a computer system, the programmer can basically make anything rewarding or punishing. So that's one cool thing. I'm going to explain this using a pretty creepy experiment done by some researchers in Switzerland. So this picture isn't from the experiment. This is just a toy, but I felt like this picture went well with the slide title. So in this experiment, it was machine learning that they were studying, and it was intended to model biological population and changes that happen in that biological population over time. So it did show this, but it also showed us some of what would happen if AI becomes self-replicating when we haven't advanced past Kohlberg's first stages of only rewards and rewards and punishments. So these robots in this experiment, they were equipped with an external light on their exterior. They had a whole bunch of cameras on them, and there was a whole bunch of these robots put inside of a room. There were some colored circles on the floor of this room, and one color represented reward or food, and the other color represented punishment or poison. So they were put into this room, and when they found food, the external light on their body went off. So it illuminated and alerted the other robots to tell them where the food was, so then they could come and find the food as well. So the scientists took the robots that were most successful in finding the food, they added random mutations into their computer code, and then they combined the code to create these robot offspring. So they combined the code and added these mutations in order to sort of model biological mating in a population. So because the food supply was limited, interesting things started happening after a few generations. So after 50 generations, the robots evolved their programmed code to leave their external light turned off when they were by the food source. So this enabled them to sort of maximize their reward at the expense of the other robots finding the food. So at the expense of the other robots, yeah. So graph A here shows that after just 50 generations, the light turned off, basically. It didn't turn on to the same extent when it was near the food source. Graph B is just showing that they also didn't respond to the lights of other robots as effectively because they realized that it was not giving them as much information as it previously was. So basically, these researchers found that generations of robots over time sort of learned to lie. Their code was altered to maximize reward and minimize punishment. So when we think about the singularity and the potential for self-replicating robots and self-replicating machinery, we can't ignore the possibility that there would be some similar mutations or mistakes in the computer code, and this is just, it's extrapolation, but it's interesting to consider in the context of this experiment. It's also important to note that these robots in this experiment were operating solely on external rewards and punishments. So when they were confronted with conflicting interests with the other robots, they basically just learned to exploit the rewards, so they maximized their rewards in this immoral manner. They were restricted to the beginning stages of Kohlberg's moral development. They weren't thinking in terms of the later stages. They weren't thinking, is this morally right? Like, should I be thinking of the group of robots? In this case, they just maximized reward and minimized punishment. So we don't want robots like this necessarily to be in our future. So what can we do at this time in order to limit some of the negative possibilities that we spoke about? So how can we make sure that the AI in the future that is sentient will have a sufficient moral code? So because we're talking about some pretty abstract concepts, I don't know. No one knows what we can do, but I'm going to give you 3 ideas of what we might be able to do to at least limit some of the dangers. So some researchers suggest that we use value extrapolation to define computational morality. We don't want just a select few computer scientists, two computer scientists off in Switzerland deciding the moral code for this AI. We want a more universal thinking in programming this moral code. So when we talk about value extrapolation, we're talking about what humans think they should do in a situation, if in a morally complex situation, if they have all the information present, if they aren't swayed by what they personally want. So it's kind of thinking what is best for humankind. So if we model moral code in robots based on this value extrapolation, then we will eliminate the possibility of a sentient AI being based on the moral code of just one researcher somewhere off in a lab. Secondly, governing frameworks, they could be introduced at this point that would be considering these issues that I'm talking about seriously. So a lot of people think things like I'm talking about would be considered science fiction, something we shouldn't be dedicating our efforts towards. But if we look at some of the negative possibilities that might arise, then it's impossible to sort of just brush this off. When we talk about computer scientists, they don't really have a governing body. They're sort of self-regulated in terms of what I'm talking about in this presentation. So if there's a governing body who's making sure that AI researchers are going in the right direction, and is cognizant of some of the problems that might arise, then perhaps we can limit some of the negative possibilities that I've spoken about. Lastly, I talked with Dr. Pilarski about this. His belief is that we should be focusing our efforts more on training the AI and not on modeling a more complex reward system necessarily. So his belief is that we're at a point now where our computational reward systems is sufficient, but we just haven't dedicated enough time and effort into training this artificial intelligence. So when we think of how much time and effort a parent puts into developing the moral code in their own child, they spend 18 years trying to get this child to behave in somewhat of a moral way. Sometimes it doesn't even work after 18 years. But if you just think of all the time and the effort put into a human developing a moral code, Patrick Pilarski was sort of just thinking that if we put in 18, 20 years into giving input into an AI system, then perhaps we would come up with a somewhat functional moral code. So we just need to focus more on the training of this AI. So I hope that you have enjoyed my presentation. I hope that I've been able to present you with some ideas that have challenged you a bit. And at this point, I'll ask if you guys have any questions.
So in addition to training, what about the role of play? I mean, human children, they have all this period of time where they're being creative in a playful way. Do you think that's going to turn out to be necessary for the creation of morality, or do you think play has nothing to do with morality?
I think it would depend on the AI system. Like, if you had an AI that was modeled after a child in that way, then I think play would be as important to an AI as it is important to a human. So a child is learning through play what is sort of right and wrong in that social context, and play is sort of an instrument for learning certain things about what is right and wrong. So if you do have an AI that's at a level of complexity to that child and encountering similar circumstances, then I think it would be relevant and perhaps necessary for that stepping forward.
I was curious if you've looked into perhaps programming social awareness in robots. Like, to me personally, it seems like one of the things you might need to teach morality to a robot, because if you have this individualistic robot and you mentioned the reward system, obviously it might think about its own interests, and like in that experiment right there, like to what extent of social awareness did those robots have?
The ones where they were kind of fighting for the food and poison? Essentially none. They weren't considering the group as a whole. They weren't really socially aware of the other robots. All they knew is that they needed to maximize the food that they were getting and minimize the poison that they were getting. So I think, yeah, if you were to advance to the later stages that Kohlberg puts forth, and some of the stages talk about things like social justice and whether things are right for the whole group and whether what you're doing fits into your social role. So yes, you would need to model social groups effectively and also have that social recognition. So I didn't research social recognition for this presentation specifically, but again, without some sort of sentience being reached, I have a hard time believing that robots being able to recognize the presence of other robots would make any difference. They might be able to recognize their presence, even recognize the emotion on a human face, but again, if it holds no personal relevance to them, I don't know if it would be as useful as we would think it would be.
You talked about like the amount of complexity is like kind of exponential with the amount of consciousness. How did they define complexity? Because I know from my studies that a lot of things in terms of genes, like or amount of genes, we don't have a lot compared to other animals or like organisms like corn, but they're not really as complex in consciousness as us. So how did they define complexity there?
I'm not actually sure. I basically just took it at face value. I found this graph, and I do realize that I'm not sure where I stand personally on this. I just kind of proposed what these researchers proposed. But again, I'm not sure that a level of complexity is all that's required to be sentient. I haven't resolved that with myself yet, but I think it's just based on, like if you look at the organisms that are listed, while the gene number might not increase, you could talk about if you just look at the animals that are on the bottom there, then take from it what you will. But I don't think gene number was what they were going for. If that makes sense.
It seemed to me that this graph is a little bit vague in some ways. Like if you think about frogs, I know I've talked a lot about frogs and the fact that they are sort of self-aware and fish aren't. You know, they're sort of in the animal kingdom the break point for that self-awareness. This graph has awareness and intentionality beginning between viruses and plants. Yeah. And I just don't get that. I think that the person creating the graph must have done it very quickly and without a lot of deep thought and where a lot of the lines begin and so on.
Yeah, I do think the same. I use this graph just to illustrate that that AI researchers are thinking that a threshold is all that we need to gain sentience. Yeah, I don't think a virus is aware of anything also, but I just put this graph up to kind of illustrate the fact that it is a progression, and the higher stages would be where that AI researchers think that sentience is reached.
Yeah. So, do you have a question?
Well, I was going to mention about training, the idea of training, until you talked about your conversation with the computer scientist. But you mentioned like in the courtroom that they wouldn't need to know much about emotions, but I think they probably would in the case of temporary insanity. So, I guess it'd be hard to teach emotions, but I suppose during the training session, like over a long time, that I guess the program could learn from the reactions of people what the effect of emotions are, the effects of emotions.
Yeah, I think, talking about the court, being a judge in a courtroom, that was, the researchers there were proposing a very limited aspect. Yeah, there would be cases where an emotionless robot would be detrimental to justice being served. But I think it was more limited in its scope in what that computational morality would be beneficial for. Mm-hmm. Yeah. And in terms of teaching the robot emotion, yeah, I still am not sure that we are at a level where we would be able to do that. But basically, Dr. Pilarski was just saying that perhaps instead of focusing on the reward system and all that stuff, we should be focusing more on the training procedures and how long we're doing these training procedures for. So whether we can imbue emotion through 25 years of training in this robot, I'm not sure. But I think the main point was that the emphasis should be on the training and not always so much on the developing of the technology.
Yeah, thanks.
Thank you.
Okay, well, our time is up. Thank you very, very much, and we'll see you on Thursday. On Thursday, the regular class period will be taken up by 2 student presentations, and we'll have a long break, and Shauna's workshop will be at 5:30 to 6:50. So see you on Thursday. Thanks.
Thanks.